Hello everyone, this is Nepal sir from ANR Academy. Today we are going to discuss limit of a special function as extending to 0. Here the special functions are step of sin x by x and step of tan x by x as extending to 0. You people are familiar with standard results without step function. Suppose the function is of the form sin x by x and tan x by x. As extending to 0, the functional value approaches to 1. But now, whenever sin x by x and tan x by x, they are interior functions with respect to greatest integer function. That is, it is a composite function. Outer function is greatest integer function, and internally you have suppose tan x by x and sin x by x, and for which if you apply x tending to 0, then what is the value of functional value? Let us discuss today. Before going to discuss limit of these two functions, suppose that here if you select the graphs of sin x, tan x, x at a glance in the Cartesian coordinate system, after drawing all these sin x, tan x, x in one Cartesian coordinate system, let us observe the relation between these three functions and then go for limit value. Yes, here this is x-axis and this is y-axis. Draw the graphs of sin x, tan x as well as x. First I am going to draw the graph of sin x. Sine wave, this is the graph, and for negative values of x, this one is the graph. Next, I am going to draw the graph of sin x over. Next, move to the graph of y equal to x. We know that y equal to x, a straight line which passes through origin, and that makes an angle 45 degrees with positive direction of x-axis in the counterclockwise sense. So that the graph of y equal to x now, angle made by y equal to x with x-axis is 45 degrees. That is clearly angle bisector of both x and y. That makes an angle 45 degrees. Also passes through origin. This one is the graph of y equal to x. Passing through origin, this is y equal to x. Next, we have to draw the graph of y equal to tan x. See the graph of tan x. At 0 it is 0, and for positive values of x it increases. This is the graph. All the three graphs clearly passing through origin, and observe for all positive values of x, since it is tan x values are greater compared with the values of x, and x values are greater compared with the values of sin x. So that the observations here I am going to write. First observation, for all x more than 0, I can say that right side of y-axis, clearly tan x is greater function, x is middle function, sin x is least function. So that I can write here sin x less than tan x. This is result 1. Next, second one, for all x less than 0, for negative values of x, see sin x values are greater and least values are the values of tan x, and in between them you have the values of y equal to x. So that for all x less than 0, I can say that tan x values are least compared to x and x values are least compared with sin x. This is second one. Particularly at x equal to 0, what happens? At x equal to 0, sin 0 0, tan 0 value 0, x is also 0. So that the three functions are equal. I can write sin x equal to x equal to tan x, particularly at x equal to 0. With the help of these results, now let us move to find limit x tends to 0, step of sin x by x. We know that limit value of a function exists when left hand limit equal to right hand limit. So that here you need to find left hand limit as well as right hand limit. If left hand limit and right hand limit both are same, then limit value exists at that point. So that here I am writing left hand limit first, limit x tends to 0 minus step of sin x divided by x. Next, right hand limit, limit x tends to 0 plus step of sin x divided by x. Let us observe the diagram of sin, tan, x and their relations. Left hand limit, left side of 0. Yes, see here, left side of 0. For all x less than 0, you have here the relation tan x is less than x less than sin x. That result I am going to mention now. To get left hand limit, I am going to use the condition left side tan x is least, then x, then sin x. Tan x less than sin x. Yes, tan x less than sin x. Now, I am going to divide each and every term with x. Left hand side x less than 0, remember. Left side of x equal to 0, the values of x clearly negative. So we are going to divide with negative number. You need the relation between sin x and x. So that let us select this one. You have x less than sin x. Now we are going to divide each term with small x, and the small x quantity is negative. Yes, first I am going to divide with x here and then here. Since in the denominator part the quantity is negative and hence there is change in the symbol. When you divide with negative quantity, automatically there is change in the inequality. When you divide with positive number, no need to change that result. So here we got the result sin x by x, it is less than 1. This is the value less than 1. This quantity we got less than 1. Internal part, this is less than 1. When internal part less than 1, that means 0.9. If I select, applying greatest integer to the number 0.9. What is greatest integer of 0.9? That is clearly 0. So that it approaches to 0. So left hand limit we got 0. Here you got sin x by x less than 1. So internal quantity not more than 1, clearly less than 1, so that if you select 0.8 or 0.9, step of 0.8 or step of 0.9 gives the result 0, and hence left limit is 0. Next, to get right hand limit, let us use the condition, first one. Right hand limit, that is right side of 0. So more than 0 condition I am going to use sin x less than tan x. For this, x value greater than 0 and the condition sin x less than tan x. We need the relation between sin x and x. X is positive clearly. When you divide with positive number, then there is no change in the inequality, remember. Sin x divided by x, x divided by x. More than 0, both sin x and x positive. And there is a relation, sin x less than x. And when you divide with positive quantity, there is no change in the inequality, so that you will get less than symbol here. That is clearly sin x divided by x, which is less than 1. Again here the quantity less than 1. That means the same what you have for left limit, you got the same for right limit. This quantity is less than 1. Suppose that internal quantity less than 1, if I choose 0.9, what is greatest integer of 0.9? That gives the result 0. This is right hand limit. So from left hand limit, right hand limit, it is very clear that both are same, and hence the limit value of this function is clearly 0. You know the standard result. When there is no special function, simply suppose you have limit extends to 0 sin x by x, then you know the result, that is 1. Why? Because as extending to 0, particularly at x equal to 0, both sin x and x approximately same, either left side or right side, both sin x and x, they are approaching to the same quantity. So here you got the result 1. You know that this is y equal to x and this is sin x graph. As extending to 0, either from left side or right side, both the graphs are approximately same. Whenever the positive quantities are positive quantities of x values, if they are large numerals, then there is a long gap between y equal to x and sin x. But when it approaches to 0 from right side or from left side, both approaching to the same quantity in these two, right, either left or right. and both are same. So I can say that as extending to 0, sin x is approximately x. When you divide with x, automatically it gives the result 1. Due to that reason, limit extends to 0, sin x by x equal to 1. You know this. And when you apply step function, step of sin x by x, but it gives the value 0. This is the proof of limit extends to 0, step of sin x by x. In the same way, by selecting the relation between tan x and x, you can prove what is limit extends to 0, step of tan x by x. Let us discuss. First I am going to find left hand limit and then go for right hand limit. Limit extend to 0 minus step of tan x divided by x. This is left limit. Next, right hand limit, limit extends to 0 plus step of tan x divided by x. Yes, see the figure. What you have the relation. First, left hand limit for all x less than 0. Here the relation tan x less than x. In this case, clearly the value of tan x less than x. Next, for all positive values of x, x is less than tan x. In the second case, here x is less than tan x. Here we are going to divide with x, but the value of x is negative, remember. When you divide with negative quantity, what happens? There is change in the inequality. And in this case, x is positive. When you divide with positive quantity, there is no change in the inequality. This is clearly 1. This is 1. So, in this case, tan x by x, it is greater than 1. Also, the same, tan x by x greater than 1. In both the cases, internal part tan x by x, that is clearly more than 1. Assume that, suppose it is of 0.01, then what happens? Applying step to the number 1.01, then you will get the result 1. And hence, limit extends to 0, step of tan x by x, both left limit and right limit approaching to 1, and hence limit value of this function is clearly 1. You know that standard result, limit extends to 0, tan x by x value equal to 1. Also remember, step of tan x by x equal to 1. Both are same. Let us discuss an application problem. Limit extends to 0, sin of 2026x whole divided by x along with step function. Next question, limit extends to 0, tan of 2027x whole divided by x along with step function, remember. Yes, you know that step of sin x by x value as extending to 0, that approaches to 0 clearly. But here coefficient of x is given as 2026. In this question, coefficient of x is given as 2027. How to handle this question? Let us observe. You know that graph of sin x and x. This is the graph of sin x and it is the graph of x. Suppose y equal to 2026x and this is y equal to sin of 2026x. Both the graphs passes through origin and always straight line for positive values of x, straight line always more than sine graph. For negative values of x, sine graph is more compared with straight line. Both left hand limit and right hand limit I am going to cross check. Left side sine quantity which is greater compare with straight line 2026x. Right hand side sine of 2026x, it is less compared to 2026x. If you divide with x, here x quantity negative and here x quantity positive. When you divide with negative quantity, you know that there is a change in the inequality, remember. It is less than 2026 we get. And for positive values of x, no change in the inequality. So on dividing with x, what happens? Less than 2026. In both the cases, sine of 2026x divided by x, clearly less than 2026. Less than 2026, since it is, what is your answer? If you write the value less than 2026 in the greatest integer function, then you will get the solution 2025. Left side of greatest integer, left side of the values less than 2026 gives the result 2025. In the standard result, when you have simply sin x by x, you have the result 1. As x tending to 0, this approaches to 1. When you apply step function, what happened? It approaching to 0. So there is a gap, 1 unit between these two results. The same here. Without step function, suppose if you have sine of 2026x divided by x, then what is your answer? 2026. When you have step function, remember that is 1 unit less compared to standard result. So that the answer 2025. Next, this is the question. Limit x tends to 0, tan 2027x divided by x. We know that as x tending to 0, tan x by x, it approaches to 1. The same x tending to 0, step of tan x by x also approaches to 1. No change in this. Just now we discussed these two results. So that here there is no change in the result. The same 2027 you will get. So this is the way of approaching limit value of a function when those functions are having special type of functions, step of x or fractional part of x. We follow the same. Just draw the diagram and let us observe left hand side and right hand side. If both the limits are equal, then only limit value exists. Otherwise, limit value does not exist, remember. This is about today's class. Thank you so much. I hope you understand everything. The students, those who are aspirants of JEE Mains and Advanced, please like, share and subscribe my channel. Thank you so much.